Hello everyone, I'm back again with another live stream. Uh, okay, my camera is not working. Just give me a minute. A minute. Let me check my camera. Okay. uh, Hello. Hi Suraj. I'm good, bro. What about you? How are you? Welcome to the stream. So today, what I was thinking of going yesterday, actually, I was watching a video of Sean. If you don't know about him, I would say just search on it. Code Forces is like he was like he's like grandmaster in Code Forces or something. So he usually do those teaching stuff whenever there is a contest. He will do the post contest coding reviews, and he will explain the question, and he'll explain all the solution on the live stream. So he's like officially a Code Forces uh, teacher kind of thing. So yesterday he was like doing some lectures on binary search, and there he added a contest beforehand, and then he started mm, with the live stream, and he solved the problems on the live stream. So yesterday I was looking at those questions, but I was not able to solve all of them mm, because I had some tasks to do yesterday. So what I'm thinking of, I'll go to those binary search questions today, because binary search is something which is very important. And yesterday I got to know some pretty good template for binary search. So if you will stick to me with me, you will surely you will get some good stuffs here. And also you can watch in the stream of Shayan. He's Here is the name Shayan something. So he had like two contests till now, masking contest and binary search contest. So I think I would start with binary search. I don't know like bit masking. Uh, like I know bit masking, but I'm not very much into the bit masking part. So I'll have to watch the lecture before. Great, Suraj. So you wanna practice some coding questions today? So let's stick with me, and we'll solve together. There'll be a lot of interesting question. Let me open my Sublime. Okay, so let's not waste our time more. Let's start directly with the binary search questions. Can I start it like start virtual contest? Yes, I can. So my time is not 45. I want to make it 43 maybe. Hey, no, we can't. Come on. 09. 43. Okay. So we got 40 minutes before we start. Yeah. Oh, nice one. Great. Let's get this together. Let's try to solve. We may discuss on the chat, and if you have something in your mind, you can always come up with the solution, and you can tell me. So okay, let me set up my whiteboard. I haven't. Just give me a second. Oh, the contest started already. Okay. So now I think I am ready. Let me write something. Yes, I can. Good. So let's go with the first question. If you guys also want to join this contest, I will paste the contest link in the chat. You can join, and we'll solve it together. So let's go with the first question, and let's see what this question says. Interesting drink. Okay. So the question is, Vasily likes to rest after a hard work. Okay, so you may often meet him in some bar nearby. Okay, so uh, Vasily likes to rest in a bar. Okay, great. As all programmer do, he loves the famous drink Bicola, which can be bought in n different shops in the city. Okay, there are n different shops in the city. It's known that the price of one bottle in the shop I is equal to xi. So one shop, the price of the bottle is is equal to xi coins. Okay. Vasily plans to buy his favorite drink for q consecutive days. He knows that on the ith day he will be able to spend mi coins. Now for each of the days he want to know in how many ways, in how many different shop he can buy a bottle of Bicola. Okay. A little confusing question, but I think it's not that difficult if I'll get the crux of this question. So the first line of the input contains a single integer n, where n starts from 10 to the power 5. So n goes till 10 to the power 5. So we can apply the binary search because it goes till n log n, nearly in 10 to the power 6 or 7 something. Okay, so we have n different shops, and each shop, it's known that the price of one bottle in the shop I is equal to xi coins. So price of one bottle at I is equals to xi coins. So the first line input is fine. The second line input contains an integer, prices of the bottles of the drink in the ith shop. So the first one says the number of shops in the city, and each shop, the prices of the bottles of the drink in the ith shop is 3, 10, 8, 6, 11. The third line contains a single integer q. The number of days Vasily plans to buy the drink. So he plans to buy the drink for 4 days. The following q line, okay, q, 4 days. The following 4 days, each containing one integer mi. The number of coins Vasily can spend on the ith day. So you can spend 4 coins. So how many bottle print q integers, the ith of them should be equal to the number of shop where Vasily will be able to buy a bottle of the drink on the ith day. Okay, so on the first day he has 4 coins, she has 4 coin. Okay, it's he Vasily is he. On the ith day he was able to spend mi coins. Now for each day you want to know in how many different shops he can buy a bottle. So we'll have 4 output for 4 queries. Okay, so the first query says I have 1 coin. I will not be able to buy anything. The second time it says I have 10 coins. So how many? So I can buy from here. I can buy from here also. I can buy from here also. I can buy from here also. So I cannot buy from here because it's the cost is 11. So I can buy from any one of these. So answer is 4. So because 4 of them we can buy. For 3 only 1 I can buy, that is it. For 11 I can buy everything. Okay, so this will be like a typical binary search approach where I will be like kind of sorting this array, and for each query I will try to do the binary search operation. Okay, so in the binary search what I got to know from him yesterday was he was telling that we know what binary search is, right? We know what low will be and high, and then we do what we find mid from low plus high by 2, and then we check. So low is something which how to take low, and means what to take as in low and what to take in high. So if I'm considering this as like 1 based index, so 0 means I'll take low as 0. That this will say this has a meaning that it is possible that will be able to take 0 bottles. So like it is possible. So I'm taking the minimum value in this. The scenario will be that this value is possible for low. For high, I'm saying that I will take that value which is not possible. So if I say 1 2 3 4 5, so 5 I can take 6. Like 6 is something which is not possible. I cannot go till 6. Like I cannot take 6 bottles. I can maximum go for 5 bottles, right? So this is what I am currently planning, that my low will be something which is possible, my high will be something which is not possible, and my binary search will go something like this: while my low plus 1 is lesser than my high, I'll find mid. Mid is something low plus high. This is not height. By 2. Okay, so mid is like low plus high by 2, and based on some condition, if condition, so suppose if condition is true, I'm saying that try to take more. So we'll do what? We'll push my low to mid. or else will push my high to mid, and at last will return low. This is what the whole template looks like. So we removed everything like mid plus 1 or high is equals to mid minus 1 or something, whatever we used to do. We removed everything and we started with very simple approach that take low as something which is like possible, and take high as something which is not possible, and then we'll try to find the mid, and based on that condition we'll set our low to mid and high to mid, and then we'll return the low. So this is something what we are planning. And if we are having like a zero based index, so we'll simply have to do what mid, the condition will be compared somewhere with mid uh, value, so mid will compare it with mid minus 1. This is what I got to know from him, the template that he usually use. So I'll try to use this template, I'll try to understand, I'll try to grasp whatever uh, this template holds, and if there is something which I will like understand more clearly, I'll keep on explaining those things. So is it clear, Suraj? Are you with me? I think no. Okay. Let's see. Let's. Let's see if this has interesting drink. Dot cpp, and I need to save it somewhere here. So what all things are we taking as an input? We are taking number of okay, so we are taking like 5, first thing 5 as an input, and then we are having vector int city maybe, or shops of size I don't have to do 5 time loop. Do I have to do? Yes, I will have to do a loop for 5 times, so I need to declare this outside. Shop will be of size t, and we'll do integer shop see in shop shops dot not pushback, let's say shop of times is equals to shop. So we have taken the array, and now I need to take the queue queries. So after this I need to take queue, and then okay, sorry. And for every query I need to print something, right? So maybe val is c in val, and before doing this I need to sort the shops dot begin comma shops dot end. Okay. So we inserted the value. Now I need to do the binary search. Let's try creating this binary search. So whatever this binary search will return, I will be printing that. So cout binary search. What I can do is, let's create a one based index, and t+1, and initialize everything with 0 only, and let's go till t from 1, and at 1th index, 2nd index, 3rd index, 4th index, 5th index we will be storing these times. So we need to do the binary search. So binary search will take what? Will take the shops, will take this queue, not queue, val, and will print something. So let's do binary search will take shop and integer val. Based on this val I need to do, so let's set our low to 0 and height to something which we cannot reach. Oh, come on. While low +1 is lesser than high, I'm trying to replicate the same thing which he used. So he has something which is like very intuitive. Let's write few comments also, because this is the first question. I want to write few comments. Considering shops as one based index, low is something which is possible to create highs which is not possible to let's take the mid as high plus low divided by 2. Now if mid value mid is like smaller than my actual value, so if shops of mid I can move right, so my low will be like at mid, else my high will be at mid, and at last I'll be returning low. So if shops of mid value is like lesser than the actual value what we were searching for, we can shift a little right. Okay. It's shops. And I'll 0304. Okay, I am considering as one based index, and even if it is equal, then also I'll try 0415. Instead of 5 we are getting 6. Why shouldn't be right? At least my this template looks something that will not go to an infinite loop. It's like 1 2 3 4 5. 2 3 4 5, so it should be 5. Why it is 6? You think anything is wrong? Okay, I already have shop.size as one more, then also I'm adding one more to it. So yeah, right, because this is one based index already, and size is already total size will be like 6, so I've already made it as 6, so why to move forward? So 0415. So this is what our actual binary search looks like. So okay, maybe let's copy and paste and see if this binary search is giving me a correct answer or not. Problem is interesting drink. Great, accepted. So the binary search works pretty well. That this template works pretty well. I need to just be mindful while selecting my low and high, because the rest of the thing will be like will go as it is. We don't have to do any change in that, but I need to be mindful while selecting my low and while selecting my high. Okay, so first question done. Let's jump to the next question. You may have already know that a standard ICPC team consists of exactly 3 members. The perfect team, however, has more restrictions. A student can have some specialization, uh, coder or mathematician. She can have no specialization but can't have both at the same time. So the team is considered perfect if it includes at least one coder, at least one mathematician, and it consists of exactly 3 members. So there must be at least one coder, at least one mathematician, and there should be exactly 3 members. So there can be 2 coders, 2 mathematician, or all coders. A student can have some specialization. So can be a 3 coder, can be a whole as a mathematician. Okay, what is the maximum number of full perfect teams you can distribute them into? So at the first glance, what is the maximum number of full perfect teams? It looks to me like a dynamic programming question. But it is not. Note that some students can be left without a team, and each student can be part of no more than one team. You are also asked to answer Q independent queries. Okay, so each of the next so the first line contains a single integer q that starts from 1 to 10 to the power 4. The number of queries in the next each of the next q line contains 3 integers c, m, and x. The number of coders, the number of mathematician and student without any specialization in the university respectively. Okay, note that the no student is both coder. Note that the no student is both coder and mathematician at the same time. Okay, no student is both coder and mathematician at the same time. Print q integers. Why we are like having so much emphasis on this no coder, no mathematician? Print q integers. I need to print q integers. The ayat of them should be answer of the ayat query in the order they are given in the input. The answer is the maximum number of perfect teams you can distribute your students into. Okay. In the first example, here how teams are formed. The only team of 1 coder, 1 mathematician, and 1 without a specialization. So I need to form exactly 3 members. All three teams consist of one coder and two mathematicians. No team can be formed. For second also no team can be formed. One team consists of one coder, one mathematician, one without specialization. The rest aren't able to form any team. So it's like now we have 3 3 as this. So okay, for this we have like one coder, one mathematician, one without specialization. The rest aren't able to form any team. Okay, if it includes at least one coder, one mathematician. There should be exactly 3 members, at least one coder and one mathematician should be there. It's like I need to find the minimum out of these two, and this is the no specialization wala part. Okay. Like what will be the brute force way for doing this? 4 4 1. So we have 4. So how many teams I can form? I can form 3 teams. One team consists of one coder, one mathematician, and one without. One consists of 2 coders, one mathematician, and one consists of one coder and 2 mathematicians. So total 3 teams can be formed with 4 4 1 configuration. So what is the best way to form something like this? So we have 10, we have 1. Okay. So yeah, I need at least one coder, at least one mathematician. Specialization is something which can take part when there is like no complete team is not forming. It can like go in and take part without specialization. So we have 4 4 1. How are we applying any kind of binary search to this? So is it possible to form 3 teams with these many? So if I'm like doing binary search on the answer. Is making 3 team possible? How can I test it? Okay, okay, give me a minute. I'll be back. There is someone at the door. So we have this as 441. पता नहीं कुछ देख जो भी होगा फ्रिज में बनवा ले. Okay, give me a minute. I'll be back in a minute. Okay, I'm back. Okay, so how are we approaching this? Is the trickiest part. If you like sum all these things and then apply binary search, that is not a possible way. Like some 8 plus 1, that is 9, and divided by it's like 3 is possible. Yes, 3 is possible. Divided by 3 will give me 3 teams. No, this is not possible, because this 10 plus 10 is 20. 21. With 21, how many teams we can make? But we need to check each what is the maximum number of team that I can create with uh, each one of them. How can we do it? Hmm. Uh, Chat, you have any idea how we can approach to this question? See, with the help of this, how many team can I form? And with the help of this, I can form like this is 4, this is 4. With the help of these two, how many teams can I form? How will I be able to know that how many teams can I form? So first thing first, if there is no specialization student, I will try to create that many team possible by taking one from each. That will be like the minimum one I'll be approaching with. So how many are there? So like 10 are there. I can create 10 teams, but whosoever is the minimum, that many teams I can create at least. So if I look at this, one is minimum. So I'm sure that one team can be created from by taking all three of them, right? And then comes, if there is still two of them left, these two are left, then we'll try to form how many teams we can now create with these two left teams. So this is like one. So whosoever is the minimum, one is the minimum. So I'm pretty much sure that I can create one team with this, reducing one from everyone, from both of them. Now we are left with 3. Now I need to take like three members. So maybe six divided by 3 it will give me 2. So 2 plus 1, that is in total 3. Like how many members I have to divide it with? So 6 is 7, 8, 9. 9 divided by 3, that is 3. So I can like distribute them in 3 different. But what if there is like 1 and 8? I need to have at least one coder there. So this will always also is going to turn out to be 9 divided by 3. That will give me 3. So this is not possible, right? Why it is not possible? Because I have only one coder. So whosoever is like minimum if they both are equal, then it's fine. If they both are 4 and 4, like 4 and 4, so in total it will be 8 divided by 3. That is like if I take 1 from here and 2 from here, so it will be 3 and 2. 1 from Now 1 from here and 2 from here, it will be 2 and 0. Now I cannot take anyone. So 2 teams can be formed. So 2 divided by 3 will give me 2. That's the floor value. Like that's the simple logic that I need to apply. I have 1. So this is the minimum. So the opposite one, wherever is the minimum, the opposite one, if it has twice member as this, then I can take them. But if it do not have twice member, so the maximum that I can go, okay, I can apply binary search on the minimum value for the second one. For the other one, I'll apply binary search that whether taking okay, right, if 5 is there and suppose there is like 10, so if I'm taking 3, is it 6 there? Yes, so I can create 3 teams by taking 1 from here and 2 from here, 1 from here, 2 from here, 1 from here, 2 from here. So if I take 4, will I be able to create that many teams? Yes. So if they both are equal, then we'll do what? Is this a special case that both are equal? I cannot apply binary search on 1 and check whether it is possible or not. It's like I want probably 3 teams. If I have this configuration, I want to create 3 teams. I cannot create 3 teams. I won't be able to create 3 teams. So if they both are equal, what we are saying, can we create 3 teams? For creating 3 teams, the opposite should be 6. Can we create 2 teams? The opposite should be 4. But it's not. I can do like reduce 1 and then this, take this as 1 and it's like whosoever is minimum, reduce 1 from him, and with the opposite, reduce 2 from him. So it will go something like this. So whichever is minimum. Like how can we apply binary search? Okay, this is like possible until unless we reach to 0. Okay, just give me a minute. I am getting a call. I need to know like how can I apply binary search here. I know that without binary search I will be able to solve it, but how I'm applying binary search here, let me know if you know the answer. Just a minute, I'll be back. I am back. Sorry. Okay. So where were we? I need to know how can I apply binary search on this, and where should we apply binary search? So ideally, I can't see like any type of binary search over here. Uh, so okay, let's try to solve this one, and then we'll see the solution if there is any kind of binary search. So we will be doing 3 times k times, and every time we are getting 3 values: coder, mathematician, no specialization. Coder, mathematician, no specialization. Okay, and every time I'll do like solve will return me something. Coder, mathematician, and no specialization, and then we'll do NL and we'll print. So this solve will take few things: coder, mathematician, and no specialization. These are the 3 values that will take. Okay, so it will take these 3 values. Now I need to find the minimum out of them. So int mini is something called minimum of coder, comma minimum of m comma n. So out of these 3 I'll find mini, and what I will do is I'll reduce mini from, and that will be like my answer will be initialized with 0. Mini will answer plus is equals to mini if there is anything, and then from coder I'll subtract mini, from mathematician also I'll subtract mini, and from n also I'll subtract mini. Now n work is finished. What I need to do, while c is greater than 0, coder is greater than 0, and mathematician is greater than 0, will do something. So now if c is greater than m, if coders are more than mathematicians, so what I will do is mathematicians minus minus, coder minus is equals to 2. From coder I will reduce 2 and my answer will increase. Now if else so not exactly 0, it should be uh, given greater than equals to 1 uh, will not do. If coder is greater than mathematician, else if mathematician is greater than coder, m minus is equals to 2 and coder minus minus answer plus plus. Else if both are same, if both are same, then I need to check if m is greater than like any one has to be reduced to 2. So if they both are same and both are 1, then we won't be able to make a team. So if m is greater than 1 and coder is also greater than 1, we can like do m minus minus and c minus is equals to 2 and answer plus plus, and at last I'll return my answer. Okay, 130013 130013. Okay, this looks fine to me. I'm not very much sure that how are we applying binary search over here. Let's see, let's submit the code and check whether it is working fine or not. Choose the problem, that is perfect team. Oh, okay. Time limit exceeded on test 2. Now we need to apply binary search over here. How can I? Let's check my submissions and on test 2. Which test case like oh, if like c is 1 and m is 1, what will happen? Else I should like break this. There is one edge case. What if c is 1, m is 1? Make it as 0. This will like keep on going inside loop. else it's like m minus minus c minus minus, or maybe I'll like break I even I can do like break from there. Okay, now time limit exceeded on test 4. We are not getting the actual test case here. I need to imagine by my own self what is the, if this is case, if this is case, else this is case. I like simply break, but that will also I don't know how I'm like we are able to apply binary search over here. On what condition are we applying binary search? It will fail on test 4 again. So the time limit is 2000 millisecond and it is exceeding from 2000 milliseconds. I am like basically handling all the cases, right? That means I need to do something. Okay, okay. We do what? We let's skip this one for now and let's go to cellular network. You're giving endpoints on the straight line. The position x coordinate of the cities and endpoint on the same line. The positions x coordinate of the cellular towers. All towers work in the same way. They provide cellular network for all cities, which are allocated at the distance with no more than r from this tower. That each city has been provided by cellular network. Okay, that is for each city there is at least one cellular network at the distance which is no more than r. If r is equals to 0, then a tower provides a cellular network only for the point where it is located. The one tower can provide cellular network for any number of cities, but all these cities must be at the distance which is no more than r from this tower. So if it is not possible, then so on r we can apply the binary search, and then we need to check whether it is possible to do it or not. Okay, so what I'm understanding from here is like apply binary search on r and then check whether it is possible with this distance all cellular towers are possible or not. For that, first line contains two positive integers and an m number of cities and number of cellular towers. and then second line sequence of coordinates that are like cities and then the towers. Okay. .cpp. Okay, this default will be changing right now. It's like first tower and the second is like cities. No, the first is city and the second is tower. City and tower. So city and then towers. That is what the question is, right? The number of cities and the number of cellular towers. So we have city and tower. We took input of city and tower. We'll take first as city and vector int cities, which will be of size C, towers, which will be of size T. So we'll take values, cities of times is equals to val, and I need another for loop which I will take as tower from towers and C in tower. Now after this I need to sort both cities and tower. Cities dot begins tower TOWER. Okay. Now what I need to do is I need to do something. Okay, I need to apply binary search on R and then to pointer for cities and towers. So that is it possible or is it not possible? I'll send cities and towers in this binary search, and I will accept this binary search vector in 10% cities comma vector and towers. Now I need to take low something. So something that is like possible while I'm taking low. So low can be like can start from -1, that if it is not possible with zero range also, so it will go till -1. So low can be something as -1. High can be something which is like not possible. uh, so the distance, the maximum distance, so it will always come down to, right? So uh, if my b it's like 10 to the power 9, uh, 1 billion, then I can like 2e9. Let's take something which is not possible. So 2e9 is something which is like not possible. It will always stop before that only. So while low plus 1 is lesser than high, I'll go med is equals to high okay. I'll have 2 pointers and a kind of a flag which will tell me that it is possible or not. So maybe bull flag which will be set to true initially and will have 2 pointers left and right. Now while uh, city, and let's check tower, and instead of mid I'm saying that this is the radius that I am looking for. So if city, while city is lesser than cities dot size and tower is lesser than towers dot size, if both are lesser we'll move forward. So I'll check if the current city like when it is like not possible. If the distance of current tower if current tower distance is greater than city and the distance from this to this is like greater, I will say that it is not possible. So if towers of T is greater than cities of C, is like one step ahead. And uh, mm, so I should like I can also make it something much more better. I can add this if condition, but if I do not want to add. So like if the absolute distance from cities of C minus towers of T, if the absolute difference between both of them is greater than R, mm, then I would say move increase the tower. Else if it is like lesser than, then increase the city. Now if city is like lesser than cities dot size, that I was not able to reach to the end, that so then I don't need the flag. So if C is lesser than cities dot size, I would say that it's not possible. So if it is not possible, then I should increase the radius. So R, my high will come to R. Else if it is possible, I'll try to reduce. So low is equals to R. And at last I'll return low. Ouch. uh towers. Okay. Oh, I did not even initialized it. Huh? Nine 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 nine. Oh, oh. Oh my god. Okay. How is it even like possible? 9999. Oh, sorry. I did opposite. If I'm not able to reach, I need to increase, right? And if I'm able to reach, I need to decrease. The output it is saying is 4. Let's try and some. I'm not sure if I'm able to, if I missed any of the test case. Again, time limit exceed. Is it something that I'm doing wrong? It shouldn't, like the binary search is not working properly. That is what. This while loop, will it fail at any case? If the distance is like greater than r, then move the tower, else move the city. If c is lesser than cities dot size, so low will be set as r. How come we are not able to find the answer? Why it went TLE? But how? 2E9. Why time limit exceed? Okay, is it something? So the values are like very big. Maybe I'll take long instead of. So mark this. the typecasting is main must return integer, is it so? Request for members and densities, which is no, but long will also, I don't know, is it so? Maybe I'll try with long. I don't know why it is the test case is failing. Oh, got it. Oh, that was due to long. Now let's go to the next question, which is travel card. Too easy. Problem. I'm not saying that this question is too easy, but let's see. A new innovative ticketing system for public transport is introduced in Pittsburgh. Now there is a single travel card for all transport. To make a trip, a passenger scan his card and then he is charged according to the fare. The fare is constructed in the following manner. Oh, so what if the second question is also due to long? Can I try it? Is there a find and replace? No, it is still failing. There's something else. There is something else to this. Cool. I will look into that. Okay, let's go to the next question. A new innovative ticketing system for public transport is introduced by Bytesburg. Now, there is a single travel card for all transport. To make a trip, a passenger scan his card and then he is charged according to the fare. So, there is one single travel card for all. Okay. A ticket for one trip cost 20 Byteland rubles. A ticket for one trip, total trip cost 20. A ticket for 90 minutes cost 50. A ticket for one day, 1440 minutes, cost 120. Okay, so this and these are the three tickets. Ticketing. Note that a ticket for X minute activated at time T can be used for trips starting in time range from T to T plus X minus 1 inclusive. Assume that all trips take exactly 1 minute. To simplify the choice for the passenger, the system automatically chooses optimal tickets. After each trip starts, the system analyzes all the previous trip and the current trip and chooses a set of tickets for these trip with the minimum total cost. Let the minimum total cost of the tickets to cover all trips from the first to the current A, and a total sum charged before is B. The system charges the passenger the sum of A minus B. Okay, you have to write a program that for given trips made by a passenger, calculate the sum of passenger is charged after each trip. Okay, the first line of input contains integer number from 1 to 10 to the power 5, the number of trips made by passenger. Each of the following n line contains the time of trip. Okay, so it's saying that I have a single travel card to make up trip, and we are charged on that card according to the fare that we have. So a ticket for one trip, a whole trip will cost you 20. A ticket for 90 minutes, so 90 minutes can be like we can go, we can come, anything we can do in 90 minutes, any time, as many times as we can, for 50 Byteland rubles. Okay, a ticket for one day, that is 1440 minutes, cost 120 Byteland rubles. Assume all trips take exactly 1 minute. Okay, what? The ticket for X minute. Let's look at the example to understand it more in a more better way. So we have three number of trips made by passengers. So there are 3 trips that made by passengers. So for a single trip, we are being costed 20 byte land rebels, right? So whosoever is watching my stream, please do try this question. This is a good question, I would say, uh, and I would recommend you to solve these questions. And also, if you can like type something in the chat box, that will be like really great. Or you can provide some idea on how to solve these questions. That would really be amazing for me, at least, to know that you guys are also working on this question. Okay, so print the sum of print the sum the passenger is charged after it. So this is like a minus b is the sum that is being charged to the passenger after each trip. So we have 3 trips that we made. Whatever trip is, I don't care from where is it going, trip or we are coming back. Trip is a trip, and for every trip we have some charge. So he made a single trip. I A single trip takes 10 minutes. Right. A single trip takes what he's saying is like, I want to do a 10 minute of trip. So I would like spend $20 for this. Is it bucks or something? Byte land rubles. 20 rubles. RUBLES. Okay. Now another 20-minute trip I took. So in total till now 30-minute trip is what I made. So again I will like take 20 rubles for this. So in total like 40 rubles we made. For 20 rubles more we want for this. For next 30, so total 30 is 60. Now total is 60. So if we take again a 20 rubles, what will happen, will our cost will increase from 20, 40, 60 rubles. But what if we take a ticket for 90 minutes for 50 rubles? So if we take for 50 rubles, how much do I have to spend here? So like subtract it from the previous one. This one should store like 40, and 50 minus 40, that is 10 for this. So the flow is something like that. Okay, it's saying something like that. So let's write on the second example. So I'll be having like two sums continuously going on. And always the next value will be like in the increased way. So like we have 10, we have 10. So for 10, how many rupees do I have to spend for this? I'll have to spend 20. So let's write it beside 20 rupees I'll have to spend. For next, the total time and the cost. We need to somehow reduce the cost. Let's see how what this example should give us some kind of intuition on how to approach to this question. So adding 13 to it will give me like 23. Still we have like we can spend 20 rubles. And what if we take a 90-minute, that will cost me like 50 rubles. That is not recommended. So again I'll take 20 rubles. So till now 40 rubles is what I spent. Now for the next I have like 45 minutes. So 60 60 68, right? For 68 minutes, if we add another 20 rubles, that will cost me a total of 60 rubles, which I don't want. Like 50 ruble is like something lesser than 60 rubles. So I will like use 50 rubles here, which will like give me a cost of 10 only. The difference from past is like 10 only. So what did I do here? What did I do? I added like for a single trip I can add like give 20 rubles. If so, it's always advisable for a single trip to try to make it like add a 20 ruble. And if it crosses either more than from 50, or we have one more minute, that is rubles. We are working on rubles, right? Only one B is there. BLES. We are working on rubles, and this is like cost time. So adding it gave me like 40 plus 20 will give me 60. Is it something better that I have in my this so 50? So what I said is take a 90-minute of 90-minute ticket or pass, which will cost you of 50 in total, and move forward. Okay, till here we are done. Now next is like adding 46. adding 40 will like 100, 108, and 6 added to it will give me like 114. Now 20 can be added to this for a single trip, so it will be like 70, and the difference will be of 20 only. So we were at like 46 at 20. Okay. 1 2 3 4. 1 2 3 4. Adding 46 again is giving me like 114 minutes. So here what I did, it took a 90-minute pass. Which will be like I took a 90 minutes pass from here, so 68 plus 90, so 1 till 158 minutes we can like have anything, we can go. So for this it costed 0. I was thinking of something else, like if I take a 90-minute pass here, like if I take a 90-minute pass at start only, we would have been able to take this and this for free. I don't know, kind of weird thing. Okay, fine, if it is like till 158 I can go. Let's see. So 46 I added, then add 60 to this, which will be like 174, which is like beyond my 158 minutes. Then I'll have to take a single trip pass for this. So if I take a single trip pass, that will make a cost me of 20. Now for next is 103. Adding 103 is like 2 7 7, which will cost me 40 only, so 20 again will spend. Why? I'm not getting it, how it is like being, the passes are being sorted. For 174 it was beyond, so we took a $20 for a single trip. Now for 277 I'm taking no pass. For 115 also added, I'm taking no pass. What is happening? And I'm not able to understand it properly. Is it something? In the first example, the system works as follows. For the first and second trip, it is cheaper to pay two one trip tickets, so each time 20 rubles is charged. After the third trip, the system understands that it would be cheaper to buy a ticket for 90 minutes. This ticket cost 50 rubles and the passenger had already paid 40 rubles, so it is necessary to charge 10 rubles only. So here what will happen, like 50 will be carried forward. The difference is like 0. It took a 90-minute pass over here. 50 carried till 158. I can go with this pass. The next is 174. I need to take a pass which will like give me a total spend of 70 rubles, and one, two, three, four, five. Five we took up a single trip pass, so the difference is like 20. At 277, the next trip I did not take any pass. Are you understanding this question? Like, what is the approach or what is the way is thinking on this? Let me know if you are understanding this question or not. I might paste this link on the chat. Try this one once. I need to understand like how and why we are like costing 0 0. We took a 90-minute pass over here. So it'll go from 68 to 90 minutes. That is 158 till 158. So for this 114 we are costing like will be costing it costed 0. For 174, because it is going beyond 158, so I need to cost it. If I take a 50-minute pass and a 90-minute pass, so at 174 plus 90 would be something else, but I'm adding one like 115 minutes. 5 1 2 3 4 5 60 added till here is like 60, and then 103 added, which reached to 277. Okay, I need to solve this question at any cost. I want to solve these questions. Travel card, two easy problems. I'm not sure about random task, but I need these two questions at any cost. Okay, what I will do is I'll take a 10-minute of break. After 10 minutes, I'll come back to this question again. I'll try to solve this question once more and see whether this is working or not. Uh, Else, we'll look into the solution for this, like how the explanation is. I'm not getting why we are having 00. Try it if you are watching the stream. Try it by your own. If you have any clue or any idea what is happening over here, let me know. Do let me know. I'll be back in 10 minutes. Don't go, please don't go anywhere. So stay with me. I'll be back in 10 minutes. Okay, thank you. Okay, I'm back. Okay, finally. Let's see where were we. Let's understand a question again. Note that a ticket for X minutes activated at time t can be used for trips started in time inclusive, assuming all trips take exactly 1 minute. The system automatically chooses the optimal tickets. After each trip starts, the system analyzes all the previous trips and the current trip and chooses a set of tickets for each trip with a minimum total cost. Let the minimum total cost of the ticket to cover all the trips on the first to the current is A and the total sum charged before is B. Then the system charges the passenger the sum A minus B. Okay, let's try it again. Let's see. What is it saying? 20, 40, 50, 60, 70, 80, 90, 110 and 120. So 120 rubles total minutes for 1440 minutes. So the first thing is we need to understand the question only, then only we will be able to answer it properly. If you don't understand the question, how will be able to think on the solution part? So we have for 10 minute, this is minute, this is my ruble. Whosoever is watching my stream, please let me know if you have any idea. Please always welcome for writing any comment. So we have 10 minute 20 rubles because this was the first ticket. So for 10 minutes 20 rubles is the minimum that we can spend. For next 13 minute the total price is like 23, so we can again spend a 20 ruble for this. The next we have like 45 minutes, so it's 68. So if we spend 20 more rubles, this will be like 40 minus 20, like, so if we spend 20 more rubles over here, it will be 60, but we do not want that. So for 45 minutes we have like 68. We can we can spend 20 more rubles. That will be like a total cost of 60, but we can spend 50. We can take the second pass, and that will cost me of 50 rubles for all these travel trips, and that will only cost me 10 more. So 10 more difference. Now till here it's fine. Now 46 is more added. Add 40 to this. 108 plus 6. 114. So it took a 90-minute pass here. One, two, three. So it took a 90-minute pass here. That will go from 68 plus 90. That is like 8 and 15. Till 158 it will go. This pass will work. So for 114 we spent 0 because it is included in 90-minute pass. Next we added 60 to it. We add 60, that is 174, which is going beyond 158. So we need to spend 20 more rubles. That will be costing me 70. We still have a cost of 70. Why I will take a like here, if I take a 90-minute pass, that will cost me a 50. How is this even working? Just very much, it's weird how. Okay, what I can do is I can look into the YouTube video which Sayan explained. Maybe that'll give me a better idea on how we are working on this. So let me open his playlist. I've just muted. The audio is not working for this. Maybe I'll try to. Okay, just a second. If what this is something where I'm doing uh, wrong. Okay, maybe let me try it. Think in one more way. So at time 10, he is like going for a trip, so he has to pay like $20. At time 13, he has to again pay $20, 20 rubles more. So that will be like a total of 40 rubles. At time 45, if he pays more 20, it will be 60 on the total, but 50 is smaller than 60, so he can use 50. And if he is using 50, that means it's a 90-minute pass. So 90-minute pass is from 45 till 90. This pass will work, right? Till 135 it'll work. So at 46 he'll spend nothing. So 50 is only till 126 is should be like, why he's spending 20 after 46, like at 60 he wants to travel again, but he has taken already a 90 minute pass. I need more details. Instead, we is saying 50 at the beginning. It's okay. Uh, let's make it more clearer that this 10 is not our main thing is starting from here. Okay, let's calculate. Okay, I got the question now. This is not included. Remove that part, that is input from 13. I don't know why I was taking this as an considering this that as a minute, because that was like in ascending order. So for this I spent 20 bucks, $20 rubles. Next is 45. I spent 20 rubles again. For 46, it's a similar case. I should be spending 50, which will take me till 90, right? So 10, a 90-minute pass. Now at 60, I will like spend nothing. It's like 50 and 50. For 103, because 90 is crossed, I did took a 90-minute pass from here. So now it makes sense. For 103, again we'll take a 20. So it's 70. So for 115, okay, just to give me a second, I'll be back. Sorry, but I needed to. Okay, I'll continue. Still, the second example is pretty little skeptical for me. Like till this, I'll take a 90 minutes pass from start, so the 60 will also be included in that. So from start, right? Sixty plus 77. So 13 plus 90 will be. So this minus 1. So till 102 inclusive will be able to work out. So this will be included in that. Now 103 will not be included, so I have to take uh, I would say a 90. Is it, are we taking a 90-minute pass again here? Or is it a 70-minute pass? A 20-minute pass if I take, then it'll be 70. For 103 we had 1 2 3. We had a 20-minute of pass. Now 115. Why the cost is like 0 and 0 for 115 and 126? Like we are taking a 90-minute pass somewhere here. It's irritating when you don't even understand the question. Okay. My god. So he's saying buy a 20-minute pass over here. Very weird. This question is really very weird. Let me get read the whole solution. Okay. So the question has only one twist, I would say. So for this, suppose I bought a pass for 115. What I would say is like buy try to buy a 90-minute pass. What will happen if you buy a 90-minute pass? You will like reach till here, till 45, and then the value which is not covered is like this, plus 50, that will be like 70, so the difference is like 0. That is why we are, oh my god, that is why we are like doing 0 over here. For the next one, 126, we have we did what we checked for 90-minute pass, so 126 minus 90 will be like 12, 36, so 36 is somewhere here. Again this will be covered, this will not be covered, so it will be again 70, so again difference is 0. So the minimum will be like added over there, minimum cost. Now I actually understood the question also, and so the question was not that difficult. Something, the subtraction part was like kind of important over here. What more cost you would pay while traveling? Because you already paid that much, right? Okay, fine, let's solve this travel card. This is not that difficult though. The main part was like to understand. So for the first line is the number of test cases every time. So every time we'll get some time in ascending order. It will be probably uh, they're given in ascending order. So most probably I will be taking long only. Consider it as long minute. Minutes. See in minutes. So every time I'll have to store the value. maybe dt plus 1. And I can start from 1. Take the minutes and always like whatever answer I'll return, I'll just have to see out that. I'll be doing the binary search operation on this dp at index times. This is the minute on that index, and then we'll do indel. So this is binary search might be returning long. We will be getting a vector. We'll try to solve the binaries. This okay. What I need is it's like dp of idx will be updated with dp of dp of idx minus 1 plus 20, or dp of idx will be equals to minimum of dp of I need to like find that position. Should I go for upper bound or should I go for lower bound? So current is like the minute is not included. So the minute minus 1 minus 90. So exact there will be 1 minute of difference. Let's check. What happened? No. what is happening. Just a second. Okay, so where were we? We needed to know whether we will be. So we had like 103, right? So 103 minus 90 will give me something as 13. So the lower bound will give me exactly 13, but 13 is not included. Why? Because from 13 plus 90 will give me 103, but till minus 1 we are going. So till 102 only we are going. So it's something currently like 103 minus 89. If I do 89, that will be like 14. So if 14 is there, then do, or I could simply do upper bound and do the job instead of like doing. We can do lower bound here. If 14 is there, or if there, then go to 14, or not, then go to like one more than that, or we can do like upper bound over here. So upper bound will like always work. So maybe I'll try with the upper bound. dp of upper bound of dp dot begin comma dp dot end comma the value that we are searching for. Minutes minus 90, right? Minus dp dot begin. So this will give me idx2. Now if idx2 is like greater than 0, then dp of idx will be is equals to minimum of dp of idx2 minus 1, whatever value it contains, plus 90, or dp of IDX, whichever is like minimum. It's a 1 day pass, so which is 1440. And same thing if I dx3 is like greater than 0. Sorry, 50 120 RDP of IDX. It's 2020. Oh, I haven't stored time. I was working on the DP. No, I need to work on the time and not the DP. Past time also. So I will be accepting this time over here. Now dp of idx is equals to like dp of idx minus 1 plus 20. Now this is not something dp dot begin. This is something time dot begin, time dot end, time dot begin. T plus I. You handled it really nicely. If IDX1 is there. Okay. But why mine is not? TF5 is the minutes that we are having minus 90. It will give me something. So kind of DP of IDX will be updated with minimum of DP of IDX. And if it is like going beyond like it is 0, then that 0 plus, so I do not have to do this. DP of IDX will be if minimum of if IDX2 is like greater than 0. If this is the case, then this, else direct 50. And the same logic will be here also. If IDX 3 is greater than 0 and DP of IDX 3 minus 1 plus 120, either else 120, whichever is like minimum, this should update it to 10. Right, because if it, even if it is going beyond, I shouldn't be worried about that. Let's see. It's 20, 20, 10, 0, 20, 0, 0, 20, minus 40 and 20. Oh, how come it's minus 40? Even if it started with no, because I don't want this to get disturbed. And in time of times and the same index we are updating for DP also. Why for third last till 80 till line number here it's fine, 150 it's fine. For 256 it is not. For 256 it's saying minus 40. But why? For 256 we got the minutes as 256 and we updated the times of times as 256. It's like dp of I. If I do this, it is the output. Seventy. For 256 it is saying 50 minute pass. No, it's not possible. So it's 90 plus 20. Firstly it will be updated with so it's 90 plus 20, 110. So this will be like updated with 110 and 256. Minus 90 is like 16. Right now it will be 166. एक 10 5 15 एक 16 हाँ right, it's 166. So 166 is nothing, this only. So the upper bound minus 1 is like 150. 150 as 90. So 90 plus 50 will be, if it is greater than 0, then dp of I index 2 minus so 90 plus 50. So this is for like 50 travel cost, that is 140 and currently it is 110, and this is 140, and then 1440. If I subtract, that will go to 0th index. This is fine. For 256, it is not going to be. See out minutes, IDX2, IDX3, Endel, and don't print this, neither this. $256. The index it is saying is 11. We have like 1 2 3 4 5 6 7 8 9 10. Eh? Weird, huh? Why for 256? Like IDX2, why it is like 11? What? How is this even possible? For 1440 it is fine, and for 516 is also fine. For 516 minus 90, the index is giving me 10. Zero for this 256 minus 90. Six zero 1 2 3 4 5 6 7 8 9 10. How is it possible? Uh, I do not understand. This upper bound is why it is giving me something like this. Okay, then why it is behaving this way, I guess I know now. So maybe what I'll do, I will not do it. Okay, because we are starting from, so I should be like time dot pushback 0. I am like converting it into one based index, so it'll be like 0 1 2 3 4 5 6 7 8 9. So for 256 it's 256 the upper bound. 516, so it will be 516. Now it looks fine. Minus dp of idx minus 1. Let me print this. I don't need this. 2020 10 0 20 0 0 20 20 10. This should be like 20 20 10. Oh, fine. The only thing I didn't need to check is long. I took everywhere long. Okay. So this travel card solved was like kind of trick just to understand the question. I was not able to understand the question, because if I would have understood the question I would have came to this solution, because this is not that difficult solution. I can say that. Let's try this one also. I'll solve this one also, and not sure about the last one, but I'll see to it. So you are preparing for an exam on scheduling theory. The exam will last for exactly t milliseconds and will consist of n problems. You can either solve problem I in exactly ti milliseconds or ignore it and spend no time. Exactly t milliseconds and will consist of n problems. You don't need time to rest after solving a problem either. Teacher considered some of the problems too easy for you, thus he assigned an integer ai to every problem I, meaning that the problem I can bring you a point to the final score only in case you have solved no more than AI problems overall, including problem I. Formally, suppose you solve problem P1, P2 till Pk during the exam, then your final score S will be equal to the number of values of J between 1 and K, such that K is lesser than equals to A of Pj. You have guessed that the real first problem of the exam is already in front of you. Therefore, you want to choose a set of problems to solve during the exam, maximizing your final score in advance. Don't forget that the exam is limited in time and you must have enough time to solve all the chosen problem. If there exist different sets of problem leading to the maximum final score, any of them would do. So the n is like 2 into 10 to the power 5. T, the test case is t is like 1 to 10 to the power 9. ei will be till n to 2 into 10 to the power 5 and ti will be like 10 to the power 4. The problems are numbered from 1 to n. Hmm. Okay, I need to understand this problem statement. Okay, so you are preparing for an exam on scheduling theory. The exam will last for exactly t milliseconds and will consist of n problem. Okay, so the exam will last for t milliseconds and will consist of n problems. So it's like let's take for the exam is for 2 hours and will have like 20 problems. You can either solve problem I in exactly ti milliseconds or ignore it and spend no time. So every problem can be you can solve you can either solve problem I in exactly ti milliseconds, so ti will be given to me, or ignore it and spend no time. So if I want to solve it, I will solve it or I will spend no time on it. You don't need time to rest after solving a problem either. So no time for resting. So we'll directly jump to the next question. Unfortunately, your teacher considered some of the problems too easy for you. Thus, he assigned an integer AI to every problem I, meaning that the problem I can bring you a point to the final score. The problem I can bring you a point to the final score only in case you have solved no more than AI problems overall, including problem I. Meaning that the problem I can bring you a point to the final score only in case you have solved uh, no more than AI problems overall. Okay, so I should not be solving more than AI problems overall. Formally, suppose you solve problem P1, P2, till pk during the exam, then your final score will be equal to the number of values of j between 1 and k, such that uh, k is lesser than equals to a of pj. You have guessed that the okay solved problems. I have solved these many problems. Then your final score s will be equal to number of values of j. K is lesser than equal to a of pj. You have guessed that the real first problem of the exam is already in front of you. Therefore, you want to choose a set of problem to solve during the exam, maximizing the final score in advance. Don't forget that the exam is limited in time, and you must have enough time to solve all chosen problems. If there exist different sets of problems leading to maximum final score, any of them will do. The number of problems in the exam and the length of the exam in milliseconds respectively. Each of the next n line contains two integer ai and ti. The problem are numbered from 1 to n. The problems are numbered from 1 to n. So I need to maximize my final score. Your maximum possible final score. Output a single integer, the number of problems you should solve, the indices of problems you should solve in any order. If there are several optimal sets of problem, you may output any of them. So input is like there are 5 questions, 300 milliseconds. So 1, 2, 3, 4, 5. So these are the 5 questions. And 300 milliseconds is the time for me. So the next is AI. That's the problem. No more than AI problems overall. So if I haven't solved more than 3 problems overall, I will get. You can either solve the problem in exactly problem I in exactly ti milliseconds, or ignore it and spend no time. So you can solve it in 100 milliseconds. So the first question 1, 2, 3, 4, 5. So the question numbers are in serial. These are my AI for that, and these are the time, how much time I will be able to solve. I will take to solve this question, right? Okay. So every question will bring me something. So I need to like understand this AI concept. Unfortunately, your teacher considered some of the problems too easy for you. So if there was no AI, I knew that I could have like maximized my answer by selecting all the minimum milliseconds until and unless I reach 300. So that would have been like very much easier for me to sort it and select the minimum until and unless I reach 300. So that was like very easy. So now they want me to have some twist in this. So unfortunately, the teacher considered some of the problems too easy for you. Okay. Thus, he assigned an integer AI to every problem I, meaning that the problem I can bring you a point to the final score only in case you have solved no more than AI problems overall. Only in case you have solved no more than AI problems overall, including the problem I. Means if I haven't solved more than 3 problems overall, then I can take a point from this. Kind of. So let's see the first example. You should solve problem 3, 1 and 4. 1, 2, 3, 1 and 4. It's like 1, 2, 1, 2, 3, 1 and 4. In this case, you will spend 80, 100 and 90, and that is total of 270 milliseconds, falling within the length of the exam 300 millisecond, and even leaving yourself 30 millisecond to average. That is not the part of the solution, but still fine. Problem 3 and 1 will bring you a point each, while problem 4 won't. Your score, you will score 2 points. Problem 3 and 1 will bring you a point each. Problem 3 is like 1, 2, 3, 4 and 5. So how 3 and 1 will is giving me a point over here. Question number 1. Problem 4 won't. At least no more than 3 problems should be solved before this. Is it something like this? He assigned integer 8, meaning that the problem I can bring you a point to the final score only in case you have solved no more than AI problems overall. So it is saying overall. So I have overall solved 3 problems. So this will not give me any point. This will give me 1 point. This will also not give me. No more than AI problems. Okay, more than AI problems. So I solved 3 problems, but not more than that. So this will give me a point. This will give me a point. This will not, because I solved more than AI problems. For this, I have to 100 millisecond, nothing. No more than overall he's talking about. So something it's like, can I solve this? Just a second. Okay. Hmm. Interesting, huh? So now I need all the three things as an output. Not only the score, final score, and not only how many questions I'll be solving, but even which questions I'll be solving. Okay, and this is some kind of a binary search approach that we are applying on it. By looking at the question, I don't know even that this can be solved using binary search. Okay, let's see. What can we do? We have like 300 milliseconds given. We can select any of them, any of the question. Might be possibly if I sort it on the basis of less millisecond, but that'll create a problem because AI is something different. So what if I have a constraint on AI A that I'll be selecting values not more than 3. If that fits in our range, like let's solve 3 problems. What if I apply binary search on problems? So it will say let's solve 3 problems. Is it possible for me to solve 3 problems and also maintain my AI? I need to somehow select optimal things. It looks like solving this problem too, but it'll take 300 milliseconds. I cannot take this. So this problem can be solved in 90 milliseconds. So if they are same, based on this, if I sort the array, then I need to somehow work on this, because this is like, this will always increase. So if I want to like maximize the point, uh, I will always select those AI whose values are greater. I'll try to select those AI whose values are like bigger value. I'll start from there. And if there are multiple bigger values, I'll try to keep the smallest value at the top. So because that will give me a point. So if I sort based on A, so I can see 150 and 80 are there, so 4 with 80 and then 4 with 150, and then we will be having 3 as 100 and then 2 as 390, so 2 as 90 and 2 as 300. Now if I say uh, this is millisecond, I will be 1. If I solve it like till this millisecond, mm, no, not on milliseconds. Now we have solved, we can like apply binary search on possibly on the number of questions. Like let's solve 3 questions. Is it possible to solve three question? 4 always take the one minimum. So 80 millisecond, 150 added to this will like give me 230 milliseconds. Still I'm able to, like, if I pick these two, I have still left 70 millisecond, but I cannot solve any of those questions. So the maximum point that I can make is to do I need, I want to choose a set of problems to solve during the exam, maximizing your final score in advance. Don't forget the exam is limited times. You must have enough time to solve all the choosing. If there exists a set of problems leading to the maximum final score, any of them will do. So this answer can also work like this is what index corresponding to that. These two index can also be returned, 2 and 3. That will give me a score of 2 maximum. So I cannot, so if I add this, there will be like 230 plus 100, 330. I might try to reduce the window size. So this will tell me the minimum number of questions points that I will have, maximum points that I will get. So minus 330 minus 80 will give me 250 again. Plus 90 wouldn't be possible, so 150 will give me 100 plus 90, 190. So we have till here as 190, and then if I take this, I cannot like make more than 2 score. So will it be possible? Like, will this logic? What I'm thinking is sorting on the basis of A, then using sliding window. Keeping time in mind. Okay. But I don't think that this. I'm not sure that this will give me an optimal answer. But I am pretty much sure that we could sort it based on A of I in increasing order. Let's see how he explained it. Correct. If I'm solving, uh, so it's saying that if I want to solve three questions, I'll take all the values whose AI is greater than 3, and among those, I will consider all the values whose values are lesser than whose like who all are based on timestamp. I'll sort it, and the minimum one will I will start to pick until and unless I reach. Yes, 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 yes. This is the correct intuition that I got. Okay. So if I'm solving three questions, I will like move. So that would have done like the sliding window would do my job, right? The sliding window could have uh, like solved the problem. This is just the kind of logic. Okay. Now, among all of them, I want based on time based sorting. So, like I'm solving three problems, I should not go to AI. If I'm going till two, it's not worth it. So AI till three, I'll go till three. I'll have to sort it based on time. So it is something log n for the binary search, and then n log n inside of it we are doing. So n log square n. That is how the time complexity is. Hmm. Okay. And so among them, I will be sorting on the basis of the minimum, and if it is possible uh, to solve three problems, whatever k I'm taking, then it's a yes. And if it is not, then I'll reduce the k. I'll try to increase the k. So that number of yes, and if I'm able to solve it, I'll try to add more. So then I'll reduce the k. It will run in an opposite way. So uh, okay, okay, fine then. Let's try it. Let's try it. This will not be that much difficult if whatever I'm thinking is correct. Then we'll be able to solve it. So the first input is like two integers, number of problems, and the exam length in milliseconds. So there'll be like two variables, time and exam question, and so C in Q as well as T. And in next we are getting AI. So maybe I'll create a vector. Mm. 32 underscore T. And let's take this as integer. Now nice. Vector T question points maybe or AI. For question plus plus I. So AI will be like from starting from 1, right? So then we can say that we can at least pick one question if possible, as it's possible that we cannot pick any question. So L can be 0, low can go as low to 0, and high can be something which is not possible, right? So I can even answer that also. So Q. So we'll get two things, uh, integer a and milli. So scene a and millisecond, these both will be, and I'll push it in my now. After taking everything, I will do I'll do binary search on the maximum. Okay, so milli, not milli, points. I'll be sending points. Do I need anything else except this binary search? This will return nothing. And low will go as low as high. What is the maximum AI? It can go till 2 into 10 to the power 5 only. Milliseconds can range. TI can also range till 10 to the power 4. So that is total millisecond. Okay. So high can be IE to the power 9. That's the maximum that I won't be able to reach, while low plus 1 is lesser than high. It's something that I'm saying solve these many questions. To solve is high plus low by 2. So that is like to solve high plus low. I want to solve these many questions, but I need something here. I need to know all the values who are greater than, and I need to store it. points of I of 0 is greater than or equals to solve. I'm saying that if it is possible, then time dot pushback. See, I need the index also, right? So there is like 3 things that I should push over here, as well as the I, and time is also going to be an integer vector. Time dot pushback points of I of 1 comma points of I of 2. Order can differ, I don't care about the order really. Sort time dot begin comma so this is sorted. Now I need to check if it is even possible or not. If it is possible to solve k problems, like if points of I of 0 is like greater than equals to 2 solve, and I want to solve k problems. So I've already sorted from start to end, and for I'll do is like from 0 till to solve. Or like minimum of to solve comma minimum of to solve comma time dot size. Like if simple condition, like if time dot size is lesser than 2 solve, that's a simple way I will not be able to solve these many questions. And if it is there, what I will do is I will have a sum. Sum plus is equals to time of I of 0. Now if sum is greater means what is the possibility that I'll not be able. So if to solve is greater than time dot size, if to solve is greater than maybe length, so I wanted to solve these many questions, but I don't have that much, so it's not possible. Or some timing is greater than the total points. So T also should be passed. Total time, or sum is greater than like total time. That means I was not able to solve it. Solve these many problems. So I'll put my high to mid. Else, if I was able to solve the problem, I'll put my low to mid, but also my total question. So what I will do is result is equals to solve T total questions that I can solve is this much. This will also be same. Answer is equals to C out result and then total question. no mode mid. Two two 23014. What? Let's see. I'm I'm not 100% sure that this will pass or not. Too easy. Too easy. Let's submit it and see what will happen. It'll fail. Most probably it will fail. Oh, seriously? It got accepted. Nice. Great. I was not expecting this. That this will be accepted. Was a little skeptical about this, but finally I was able to do it. I want to solve this question also, and then I can stop. Perfect team. I Let me watch this video. For perfect team. And plus one. Is it really? This is the case. Okay, nice. Perfect team. We have this low is 0, high as n divided by 3 plus 1. Mid teams, which is nothing but high plus low divided by 2. Now if mid teams is greater than, sorry, is lesser than equals to my this, and mid teams is lesser than equals to my m, and then mid teams multiplied by 3 is lesser than my total. Total is something C plus M plus N. If it is possible, then we'll set our low. We'll try to increase. So we'll set our low to mid. One three zero zero 13. Is it correct? 130013. Yes. Perfect. Paste it here. Let's see. Hopefully this should be accepted. Yes, nice. So here this too easy problem was where is that question? Too easy problem was 2 seconds and my code solved at 1 millisecond lesser than the actual giving TLE. It somehow saved. It is using a lot of memory. I knew that this question is like taking a lot of memory space, because every time I have initialized my resultant array, and every time I was creating this time vector. So this should be there should be some limited time vector. I don't know. I could have like created it beforehand and maybe reset it again and again. That might increase the time. I'm not sure. Okay, but we learned a lot. We were able to solve many questions. We learned a lot of binary search, and now I'm 200% sure that I'll be using this binary search template. I'm pretty much sure. Maybe I'll just save a CPP for binary search. Binary search template dot cpp, where I is the here. This is something. All in all, I want. So high is something which is not possible to create. Low is something which is possible to create. So that's why I'm taking low as 0, high as this. So maybe I'll should I keep it or should I remove it? Let it be. So this low is lesser than high. And this will give us the real actual template, and from now onwards I'll be using this binary search template always. This is very accurate, close to, like, I won't be changing the template uh, in a while, so this is really good. Okay, great. So we solved many questions today. We got to know something new. In every question we were able to solve like binary search questions. There are good couple of good binary search questions are also present on the code forces part. So we learned a lot. So hopefully today's contest, so I'll try to give the contest if everything goes well. So I'll be giving the contest also today. So now I think I should stop. If you want this binary search template, you can you can take it from here, or maybe even I can paste it in my GitHub. What should what you should say? What should I say? Should I paste it in my GitHub? First, let me bring it to the top here. Okay. So, okay. Thank you everyone for watching my stream. I hope I'll be back again next Saturday with the same energy, and we'll be solving more questions. And in between, I'll be watching those lectures from Sean, which I already gave you. Like, this is competitive programming with Sean. If you want, you can watch his videos too. Like, he's amazing. His way of explanation, it's not that he will do all the basic stuffs and explain you from the scratch. He will not do that, but uh, he will explain you the main crux of the question, and also he has some good amount of knowledge and the way to implement a question. So yeah, so I'll be watching more videos of him. I have watched couple of, but was not that much focused, but from now on I think I'll be watching more of his videos. So thank you everyone for being here. See you next time. Till then, I'll be solving more questions, and I'll be teaching you more things. So this is what I got to know today. An amazing template which I searched a lot all over the place, but I didn't get it. Okay, thank you. See you next week, Saturday, 9:30. Back again to another live stream. Till then, bye bye.